Hello everyone, this is Jam Jung. Today I will explain software-defined networking SDN. The contents are as follows. Firstly, I will explain introduction. Secondly, I explain software-defined networking SDN. Thirdly, I will explain ONF standardization activity for SDN standards. ONF stands for Open Networking Foundation standardization body. Firstly, open source projects for SDN will be introduced, such as OpenDaylight for SDN controller and Mininet for virtual network for SDN networks. Fifthly, I will explain security services with SDN as use cases. Finally, I will conclude this class. First section is introduction. As you can see, many topics in security, especially software-defined networking in 5G security. So the 5G network consists of 5G core network and radio access network, LAN. Okay, so data security and privacy, predictive security and monitoring and analytics, cloud radio access network security, virtualization, software virtualization security, optimization and orchestration security, SDN security, network slicing security, edge. These kinds of close to radio access network cloud is called the edge security, and service function chaining, service supply chain security, and open source and API, application programming interface security, and so on. This error is called software-defined error because traditionally telecommunication company called telcos provided internet services based on hardware intensive ecosystem. Software is not core. On the other hand, nowadays internet players such as Google, Amazon, Apple, they are using software intensive ecosystem. Nowadays hardware is just a base, not core. So there is a kind of some important change, revolution. So traditional telcos case, including AT&T, Verizon, in Korea case, KT, SK, Broadband, LG, U+, and British Telecom and Telefonica in Spain. They are usually based on this one, but nowadays they are migrate from hardware-centric intensive system to software intensive system. I mentioned Google, Facebook. Nowadays this is a Meta, Amazon, Naver, Daum, Alibaba. They are making their own data network, also content delivery network they are providing. So adaptation for survival in new networking era, telcos, telecommunication companies' interest is shift from hardware to software. Let me give you an example. Security service management. Okay, so this figure shows an example SDN-based security service. So I2NSF user, I2NSF stands for interface to network security function. So this user is, for example, network administrator. Network administrator gives some network security policy to security controller. Security controller translate that policy into low-level security policy and can configure. Okay, we assume. So network security functions are This is a virtual machine or native cloud container, such as the firewall and a filter. After that, a user can transmit the traffic into this SDN network. So this is SDN switches, open flow switches, and in the middle we have SDN, software-defined networking controller. So packet is going through, and then this switch think this packet is malicious. It forward the SDN controller. SDN controller forward the traffic packet to security services functions like a firewall and web filter, and then they can handle. Okay, if those packets are malicious, they can drop and report to administrator. There are different cycles of telco and service provider for network technology. So telco's cycle in the past, so idea, proposed, demand. Okay, so and then equipment vendor like Cisco, Juniper, Huawei, Ericsson, they get the demand from telco operators, and then they start the standardization organizations like IETF. IETF stands for Internet Engineering Task Force. Okay, so and then they make some prototype, test, standardize, and then they can make their product and then sell them, and then telcos can purchase that middle box, okay, and then deploy. So this cycle takes usually at least 2 through 6 years, okay. So this is a long time. So nowadays service providers like Amazon, Google, Meta, Apple case, this kind of cycle is too long. So they started idea, developed, deploy policy. This is usually 2 through 6 months, as you can see. The scale time is significantly reduced. This is possible because of open source project. Okay. Second section is the software-defined networking (SDN). Demand for software-defined networking (SDN). Motivation of SDN. The first one is to allow network users to construct their own network protocols and test them easily. So in the past, it is hard to make their own new protocol and test and deploy. Secondly, to allow them to implement their protocols in network software, not in network hardware. So network operating system can support that kind of extension over proprietary or standard protocol, okay, in their network system. Thirdly, to allow service providers such as Google and Facebook, Meta, to elevate the deployment speed of new services. Okay, once they developed and then easily launch according to previous cycle. Principle of SDN. The first one is SDN controller as network brain, governs network configuration and routing policy in a centralized way. Routing protocol in the internet usually decentralized way. So SDN controller try to more flexibility and strong services is possible in SDN networking. Secondly, switches with flow table. ONF case, they providing open flow table. So these switches work for forwarding the packets according to the command from SDN controller using open flow protocol between SDN controller and switches. So background and concept of SDN, you can see open innovation based on open source project. SDN networking is invented to support the creation of network abstraction to enable faster innovation in networking side. In the meanwhile, network functions virtualization standardized by European standards body ETSI, European Telecommunications Institute, Standards Institute, okay, European Telecommunications Standards Institute, okay. So ETSI, they standardize NFV for network virtualization of network system, security system, and so on. Their objective is to reduce CAPEX, capital expenditure, and OPEX, operational expenditure, and also space and power consumption can be reduced. So three trends are make a synergy nowadays. So this figure shows SDN architecture. So SDN architecture consists of three layers: infrastructure layer, control layer, application layer. So infrastructure is network infrastructure like core network, routers, switches, and base station in cellular networks. In the middle, there is SDN controller. Top, there is applications like business applications, cloud orchestration, and SDN applications. So applications and SDN controller can communicate with the northbound interface. They give some policy or their requirement for services. And then SDN controller translate that kind of policy into low-level policy or rules. And then they are transmitted by southbound interface like open flow to appropriate network infrastructure components like switches or routers or security functions. So architecture, in summary, SDN application learning this application layer, and northbound interface is interface between application layer and control layer, and SDN controller governs SDN switches according to the user's demand. And then southbound interface is used to deliver low-level policy or requirement to appropriate network infrastructure. Okay. The third section is about ONF standardization activity for SDN standards. So SDN standardization is performed by ONF. ONF stands for Open Networking Foundation. This is a standardization organization. So this figure shows ONF, the standardization body structure. Okay, so ONF board, including executive committees, technical leadership team, and executive supply advisory board, and ONF executive team, ONF lab team, something like that. So they are working various projects, and then they testing, and then they evolve standards, okay, for SDN. So this figure is the logical structure SDN network. So it has SDN controller, and this is the SDN switch. So between two components, southbound protocol such as OpenFlow protocol is used. Okay, it is working SSL, secure socket library, and TCP. And the switch case, the control path and data path are separately governed by OpenFlow table. So OpenFlow is a protocol as a southbound between SDN controller and SDN switch. Okay, so southbound interface facilitates the efficient control over the network. Okay, and according to the real-time demand, switch can handle SDN and controllers demand, and then so OpenFlow protocol is used. Okay, as a southbound. OpenFlow is a component that can change the packet forwarding way in a standardized way. So you can see OpenFlow switch contains flow table. So flow table has flow entry. Each flow entry consists of a rule for forwarding and action, drop, forward, mirror, something like that. Statistics for this rule. Okay, and then OpenFlow switch and SDN controller can communicate with each other using OpenFlow protocol to make this OpenFlow secure SSH secure SSL secure socket library can be used. Okay, and then multiple end system like host can connect it to switch, and then their traffic governed by OpenFlow table set up by SDN controller. So OpenFlow packet processing procedure is like this. Okay, so packet coming from network, and then OpenFlow switch received, and then it take a look. It's OpenFlow table for flow lookup. If there is a match, apply action. Action means forward, drop, or mirroring, something like that. No match case, the packet should be sent to SDN controller using secure channel. Also, we can make OpenFlow pipeline processing. We can have multiple OpenFlow table like this. Okay, so certain packet comes in, table 0 is used to handle that packet, and then another table also used for another services. Okay, so and so on. Theoretically, we can have n tables. Okay, after that, execute action. Okay, so multiple flow table can be used. Okay, in cascade way. So OpenFlow table I explained flow 1 up to flow n. Each flow consists of rule, action, statistics. So this is OpenFlow rule. Okay, rule case. Remember this is switch. So switch port, MAC address, source and destination, and Ethernet type, virtual LAN ID, source IP address, destination IP address, and this protocol upper layer for IP datagram, and then TCP source port, TCP UDP destination port. Okay, so this combination makes a rule. The action case, forward the packet to appropriate port. Secondly, encapsulate and forward it to SDN controller for further processing. And thirdly, drop the packet. Lastly, send it to normal processing pipeline, because OpenFlow table may be multiple in SDN switch. And the statistics, the packet and the byte counters are used. Let's move on. Section 4 is about open source project for SDN. We have two open source projects. One is Open Daylight, this is open source for SDN controller. It supports OpenFlow as a southbound interface as well as other network protocol like simple network management protocol SMP and netconf for network configuration and BGP protocol gateway protocol and list. Okay, locator and identifier separation protocol. And website you can visit, you can download Open Deadline, and you can report to many documents from this Open Deadline project. And secondly, Mininet is an emulator for SDN networks. It can build a realistic virtual network in a PC or laptop. It can run real kernel, switch, and application code. Okay, so emulation simulation different. Emulation case, the actual packet is generated. The simulation case, simplified packet is used in virtual environment. Okay, in terms of virtual case, this case one PC or laptop actual the protocol stack is used. Simulation case, on the other hand, some simplified network protocol can be used. Okay, so you can visit this Mininet website. Let's move on. Section 5 is about security services with at the end. So motivation for SDN-based security services. Okay, so in the past, this is public network, this is private network like SKKU, institutional network. Okay, so in the middle, close by gateway, the entrance of private network like SKKU, Suwon campus network. Okay, so fiber, take a look and check, inspect the package are malicious or not. So fiber reject any illegal or malicious packet as incoming request to open illegal TCP connections or packets of other illegal types, UDP and ICMP, Internet Control Message Protocol, or control for IP layer packets. And thirdly, IP datagrams or IP packets with illegal IP addresses or port number for transport layer like TCP or UDP. So in the middle, fiber provides security at the loss of flexibility and the cost of network administration. Okay, because this is a hardware box in the past. Okay, so challenges in fiber, we have fiber the features. Okay, considerations. The first, the cost of adding fibers to routers is substantial, expensive. Performance. Fiber are often slower than the link speed of their network interfaces, like 10G or 100G gigabps. Okay, and the thirdly, management point of view, managing access control dynamically across hundreds of network elements is a challenge. And the policy, it is difficult to describe what are permitted, what hosts are, what server permitted or denied. Okay, pros. Okay, within specific domains. So according to certain user or IP addresses, so generated pro can specify it. Okay, as permitted one or denied one. And the binding, packet based access mechanism is not enough in practice, since the basic unit of access control is usually user or application level. For example, proprietary protocol Skype connections for specific users are open. So in that case, simple fiber cannot handle this one. So centralized network fiber. Okay, so this is the fiber some software giving some rule. This SDN. So example, SDN controller case as a control for firewall switches can be used for firewall service. Okay, so firewall rules can be managed flexibly by a centralized server. This kinds of we can call this SDN controller. SDN protocols can be used for a standard interface between firewall applications and switches. Okay, so we are assuming this is firewall application. So to make it easy, we introduce SDN controller. So this is firewall related application to provide policy. Okay, actual firewall service is done in switches. Okay, so we can see expectations for SDN based firewall. Let's see. So five some aspects. The firstly, in cost point of view, ideally one single firewall is enough. Okay, application this contact SDN controller. Performance point of view, firewalls can adaptively be deployed depending on network conditions. Thirdly, management point of view, firewall rules can dynamically be added with new attack intelligently. And finally, centralized view might be helpful to determine security policies. Finally, binding application level rules for users or applications can be defined by software. So this is SDN based security service system. So in the middle we have SDN controller, upper layer application layer, running firewall application, or DDoS. DDoS stands for distributed denial of service attack mitigator. So some package coming. Okay, so we assuming SDN controller install new protocol using southbound interface like OpenFlow. Example, drop package with suspicious patterns. Okay, in payload. So incoming packet. So we can handle. Okay, and then high-level architecture for SDN-based security services. We already saw, right? So multi-layer management functions. So and then SDN. Okay. System can be decomposed 3 layers. The first one is a resource layer, and secondly SDN control layer. The upper layer is application layer. So we previously saw, right? This is control, this is infrastructure, this is application layer. Okay, so SDN controller layer case or SDN control layer contains application support, module orchestration for switches, and abstraction to handle switches OpenFlow table. And then resource layer support control and data transport and processing. Finally, security applications are firewall, DDoS attack mitigator, web filter, etc. So objectives of SDN. The first one is prompt action to new network attacks. Secondly, autonomous defense from network attacks. Thirdly, network load-aware resource allocation. So SDN case, certain sophisticated new service detected, and then SDN based security services autonomously and promptly. Okay, set up OpenFlow table entry to defense against those sophisticated network attacks. And the autonomously defense means SDN-based security services identify the category of network attack, such as worms and the DDoS attack. And then these services take counteraction for the defense without the intervention of network administrators or operators. Okay, so automatically network service like security service can be provided. And also SDN-based security services measure the overhead of resources for security services, and then they can dynamically select resources considering load balance between switches, okay, for maximum network performance. So requirements. The first one is programmability of network resources, okay, using SDN southbound, for example, to mitigate the network attacks. Okay. Secondly, application interface to allow the management access control policies in an autonomous and prompt manner. And also, thirdly, resource control interface is used for control of network resources to mitigate network attacks. And finally, logically centralized control of network resources to effectively mitigate the network attacks like DDoS attack. So we have two kinds of use cases to find out the effectiveness of SDN. The first one is a centralized firewall system. Second one is centralized DDoS attack mitigator. So first use case, let's take a look at this example. Malicious package comes in, and then SDN switch, okay, so investigate, and then so this one is open flow table. There is nothing with that flow, just the forward, okay, because it is unknown flow packet. SDN controller forward the packet to firewall, okay, so firewall application can handle. So if firewall regards it as a malicious packet with a suspicious pattern, okay, so in that case, okay, secondly, firewall reports a malicious packet to SDN controller, and then SDN controller take a counter action by installing new rules like dropping packets with those suspicious pattern. Okay, so in that case, the consecutive incoming packet with malicious some pattern, so they come in, and then okay, they can dropped by the switches because those new rules are installed by SDN controller. Okay. Secondly, we consider second use case is DDoS attack mitigator. So in that case, DDoS attack packets are alive at switch 1, and switch 1 suspects of flows packets within inter-arrival pattern, so the inter-arrival time is too short, and then those packets are considered some DDoS attack packets. So first of all, switch is forward the suspicious flow packet to SDN controller. Okay, and then first of all, just okay, rather than packet itself, just report that this flow is over some threshold inter-arrival sometime. So that report is going to DDoS attack mitigator by your SDN controller. And then DDoS attack mitigator compute a separate path for the suspicious flow to prevent Okay, there's a suspicious flow from blocking good flow over regular flows. Okay, so reports the suspicious flow to SDN controller, this mitigator, and then SDN controller installs new rules to forward packets with suspicious interrupt time pattern to a separate, right? So usual forwarding is this, but it forward this one. So this suspicious flows packet are randomly dropped by switch 3 to reduce the impact of DDoS attack. Okay. So regular packet is going to another path. Conclusion. This class, I explained the software-defined networking (SDN), the concept of SDN, and ONF standardization activity for SDN standardization, and I introduced the two open source projects such as Open Daylight and Mininet, and also I showed the two use cases for security services using SDN, and also we can see SDN is a cornerstone foundation for virtualized networks and security. SDN is a powerful networking tool for network softwareization. Secondly, SDN is an important part of network functions virtualization NFV framework. Lastly, SDN enables efficient networking and security services in 5G, beyond the 5G and 6G network. Okay, so if you have questions, please let me know. Thank you for your attention.